Well, hi there. So in this video, we're going to talk about the total revenue test of elasticity, which is an easy way for us to determine whether the demand curve that we're contending with is elastic or inelastic by understanding some relationships between price and total revenue. Then we're going to finish with a discussion about price elasticity of supply. So let's get started. So the first portion of this lecture is just about that total revenue test. And as a quick refresher from our last practice problem, total revenue just means price times quantity. So if you sold, for example, 5 units and they were priced at $6, 5 times 6 is $30. That's the amount of money that your company has coming in. It's not the same as profit. We're going to look at that later. Knowing the price elasticity of demand of your product can actually help you know whether if I change the price, am I going to get more revenue or I'm going to get less revenue. So it's a very valuable concept. And knowing that backwards, you can also know what might happen to revenue when you change the price. So I think I actually just said that. Burp. If I know that the demand, for example, is relatively inelastic, we'll just go through this example, and the business raises its price, well, this tells me, right, that the quantity demanded not going to change much. Right? That's what this tells me, that it's relatively inelastic. And I raised my price, so that means I'm not losing very many sales. So we could predict that total revenue will increase. I'll make more money because I raised the price and I didn't lose that many sales. Now, what we could see is that will be true by kind of doing a little bit of some numbers here. So we're going to do what's called the total revenue test of elasticity. What it is a way to tell if the total revenue is doing something and price is doing something. We can also tell price elasticity of demand and vice versa. So it's a relationship among those three variables, right? The changes in total revenue, changes in price, and the actual elasticity of a particular product. So let's go ahead and calculate some numbers first before we plot anything on these. The total revenue column is just going to be the multiplied P times Qs. So 0, 9, 16, 21, 24, 25, 24, 21, 16, 9, and 0. And so you can see the total revenue rises, hits a peak, and then comes back down again. And what we're going to do in this top graph is just plot here quantity. The largest quantity is going to be 10, and the highest price is going to be 10. And we know that the midpoint is 5, and the midpoint here is 5. And so obviously you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if we kind of connected our dots, that's our little demand curve. Right? That's our little demand curve that is represented by this data, right? These two data sets. This is our quantity demanded that we would sell at any given price. Now, if I created a total revenue graph underneath it with the same quantities, right? The same quantities, I would find something kind of interesting happens. And so here I'm connecting this 5 quantity up to this one. At the 5 quantity, that's our maximum value of total revenue. And that's going to be about $25, right? So I'm going to say 25 is right here. And obviously, if I sell at here at 0, price 0, I'm not making any money. So I have this one. And this one, price 10, 0 quantity and 0 total revenue. So I have 0 quantity and 0 total revenue in this quantity right here. So 0 quantity, 0 total revenue. And let's say maybe I went to sell that first unit, 10, 20. That first unit, 1, 2, 3, 4, 5, is going to get me about 9. And then my second unit's going to get me about 16. And my third unit is going to get me 21. And my fourth unit is going to get me 24. And so you can kind of see it starts to flatten out, and then it's going to go exactly the opposite direction. And if we did this correctly, it's actually kind of a nice, smooth little parabola. So it's okay to kind of smooth yours out a little bit. Now, this parabola is our total revenue function. And what that little parabola tells us is that there are actually different ranges of this demand curve. I kind of lied to you when I told you that a downward sloping demand curve that looks like that is just called uninelastic. What's actually true is that from one point to another point on this demand curve, it has different values of elasticity. There are different kind of responsivenesses. So there's a little bit more to this story. Now, what I'm going to find is that, let's say I go from 2 to say 4. Right? Let's go from quantity 2 or 1 or so to quantity 4. When I'm doing that and I go from 1 to 4, I know that I'm lowering the price. Right? So if I know that I'm lowering the price from, say, quantity 2 to quantity 4, right? So I'm going from 8 to 6 in terms of the price. What's happening to total revenue? 16 to 24. So in that range, I can actually say, because these two things are moving opposite each other, that there's actually a fair amount of responsiveness. And so I know that that range of the demand curve is actually the elastic range of a demand curve. I also know that if I go from, say, 6 to 9, and I'm in this lower portion of a demand curve, right? So I go from, say, 6 units to 9 units. I'm still lowering the price. Now I'm lowering it from 4 to 1. Well, from 4 to 1, my total revenue goes from 24 to 9. Now it goes the same way. So I lowered the price, and if total revenue goes down, I actually call that the inelastic range. Now, if we can go the other way, if I said that price goes up and total revenue goes down, so if they're moving opposite, I'm still in the elastic range. And if they're both going up, then I can actually also say that's the inelastic range. That's the inelastic range. So you can kind of do these in any particular order. In class, we're going to do something with our arms, and we're going to stretch out and hopefully help you kind of understand that concept. On the graph, we can actually label the demand curve and say it has a range where it's inelastic. Where as we were to raise the price, let's say we raised it from $1 to $4, we would get more revenue, right? So if I raise the price from, say, 1 to 4, I certainly lose some sales, but my total revenue actually goes from 9 to 24. And so in this range, the lower portion, we call that the inelastic range. The upper portion of a demand curve is the elastic range of a demand curve. And just so you remember, E comes before I, right, in a demand curve. The elastic range is going to come before the inelastic. Let's test that out. If we go from, say, 6 to 8, right, so we're in the elastic range, we're raising the price, our total revenue is falling. So they're moving opposite directions. That's going to tell us, so total revenue goes up, price goes up, total revenue goes down. That's the elastic range. So you can kind of use this little data table and test it out and make sense for yourself within this range of like what makes sense with these. You can go back if you're really stuck and just think through what this would look like. Now, there is one point that we actually didn't talk about, and that's this midpoint where it's 5, where actually total revenue is maximized. That point right there is actually the unit elastic point on the demand curve. And a way to think about the unit elastic point is that's where total revenue is maximized. Now, we're going to come back later and we'll talk about maybe why you would want to revenue maximize versus profit maximize. All that stuff comes later. But excuse me, for right now, it's useful to maybe tuck this away. This over on this side is the imperative for the exam. Like you really kind of just be able to know this relationship. You will not have to draw these graphs or anything like that. You will get a couple questions that will assess, do you know that the range up here is the elastic and down here is the inelastic range? So that is something that you're going to have to be able to know. But as I told you, E comes before I. Now, we're going to switch gears, talk about price elasticity of supply. In this section, it's really very similar to price elasticity of demand. It's how much does changing price, though, affect quantity supplied. So our formula is going to look much the same. As I told you in the first video, it's the percent change in the price, and that's dollar denominated. That's going to go in the denominator, right? Dollar denominated, it's in the denominator. And the percent change in quantity supplied is what's going to be in the numerator. And just remember, we've got new minus the old over the old to figure out percent change. And just as with our last graphs, we kind of interpret them as if there's very little response to a price change, right? Almost none, no quantity change in response to a change in price, then we would say that that's perfectly inelastic. There are goods and services where you really can't create more quantity in response to a change in price. You might be thinking, if there's maybe Super Bowl tickets, right? They have a fixed number of seats. They can't increase the quantity, and so they are kind of fixed in that sense. We'd say they are perfectly inelastic. You could have other goods and services, though, where it's really difficult to change the quantity in response to a change in price. Those types of goods and services are ones where maybe it takes a long time to build the factory. Maybe it takes a long time to process the raw materials. So for example, like copper wiring, right? Copper wiring, you might not think is like, oh, that's pretty easy to churn that out. You got to go get the environmental permits to dig it out of the ground. You have to find it in the ground. You have to dig it. That takes time. You got to buy the machines and all the ore refining tools, right? It's a multi-billion-dollar process to open a new copper mine. Now, open a new smelting facility to refine all that ore. Now, transport all that stuff from point A to point B, right? You might have to build railroad lines and all kinds of things. Then you've got to form it into those long coils. Then you've got to cover it in rubber. Oh, where do I get the rubber, right? So there's a whole lot of stuff that you have to do. And so you could see that maybe you wouldn't get an immediate change in quantity in response to change in price. If it's less than 1, so if this number that it spits out, remember it doesn't have units, no units. If this number that this spits out is less than 1, we'd say it's relatively inelastic. Now, if it's a proportional, like 1-to-1, where the ratio is 1-to-1, we would say it's just that kind of standard looking upward sloping supply curve. Relatively elastic means they can pretty quickly ramp up production. If the prices start to rise, they could increase quantity really quickly. That could be something like a soda maker, right? A pop or a soda maker like Coca-Cola. It's relatively easy for them to ramp up production if they need to. If all of a sudden they get swamped with orders, you just mix some more syrup with some water. Now, a perfectly elastic supply curve, again, hard to see out in the wild, but it's going to be that horizontal line like that. So that would be an infinite change in quantity in response to any change in price. A little bit of a weird one here to think about. But we do see these. These are like concert tickets, Vincent van Gogh paintings, right? You have famous people who paint paintings. But most goods are usually obviously going to cluster somewhere in the middle. All right, so hopefully that helps you understand a little bit more about what we call the total revenue test and about price elasticity of supply. I'll see you next time.